So we're starting this out. We grabbed our handout. We want to be able to solve for the following. We're looking at lines that are parallel, perpendicular, or neither, and these are in the easiest forms. We're looking at problem number 1. What's the only part that we really care about? Slope. In this case, our two slopes in our first one are the same. What does that mean that the lines are? Parallel. So this is definitely parallel. What about the next one? We have, they're the same but opposite. What do we have? Neither. In this case, it would just be intersecting is another one that we had. Neither. And what about the last pair? It's opposite flipped. Perpendicular. Problem number 8 on the test involves looking at these types and how they're related. How many solutions do we have for one of these? What does it look like to be parallel perpendicular? So we want to be able to look those up. Okay. I'm going to give you guys your answer key to your homework. So here you guys go. Miss Danielle went ahead and did it for us. Check out your answers below. Now, one thing I want to stress with these is last year, at least for my classes, we kind of steered clear of fractions. We steered clear of decimals. But we're going to be seeing it a lot more than we usually used to think about them. Okay? 1 through 6, all of them are decimals. And regardless of whether you gave me the square roots of them, it's okay if you did, and you let them as square roots, because I saw some of you guys did do that. Okay, you guys definitely did do that. That we can leave them like that. Miss Danielle put the distance formula at the top upper right. We also have the midpoint in the bottom portion. We can also use the a squared plus b squared equals c squared portion. So make sure that you guys have those in. We're going to look at more today. We're going to look at proving as we're going along with these. Negative 1.5. 0, comma, negative 1.5. Okay, you guys are checking them out. I don't see anyone really writing, so I'm going to go. Okay. What? You weren't required to graph them. You weren't required to. Which one was it?
2, I think. I rounded mine.
You don't need to round. Don't round. That goes back to another thing. Don't round your equations. Do not round. It does not help you guys to do it. Okay? I'm going to go ahead and just do 2 problems of the homework. Is there any particular 1 through 6 that anyone wants me to do? Anyone? Going once? Or just choose one? Going twice? And choose one? Pretty much straightforward. I'm going to go ahead and I'm going to do 4. Is there? Yes. But that's not 1 through 6. I mean, okay, I can do 9. 4? Okay. I'll do 9 after that, though. 4 for this right here, we're going to have 7, comma, 5, comma, 6, negative 6, comma, negative 3. So I want to be able to plot those points out on my graph. So I'm going to go over 7, to the right 7, up 5. Give me my first point there, back 6, down 3. My second point. I'm going to go ahead and connect them. So we got to find the length of that. And it's not as easy as just counting them. We can't just count. The thing that we want to be able to do, and we've seen a lot of, is we're seeing the equation a squared plus b squared equal to c squared. where A is equal to a side and B is equal to a side. And we're solving out for that longer portion. So I'm going to go ahead and create my triangle out of this. So I created my triangle. I want to be able to count everything, so let's go ahead and count it. I'm going to get 6 and 7 is going to give me what, 13? The side of it is 3, 6, and 8. So I want to be able to use these and plug them into the equation a squared plus b squared equal to c squared. I'm going to plug in my values. So I'm going to plug in 13 in one of them. I'm going to plug 8 into the other one. 13 squared. Or did I do it? No. 169. Should have known that. Plus 64 equal to c squared. 69 and 64. 169, 164 gives me what? 2. What is it? To solve for this, how do we do it? Square root. So in this case, you should have got 233, square root of 233 equal to c. What's the decimal representation? What was it, 15? So these would have both been acceptable. This tells me this full length right here is 15.3 units, or square root of 33, 233. Really big, not too big. Okay, so that's that. Okay, that one's that one. Let's clear it. The other one I want to be able to do is, let's say for number 9, for a midpoint. -4, comma, -7, 2, 7. Oof. Our midpoint, the midpoint formula, is going to be x1 plus x2 over 2, y1 plus y2 over 2. So that's the equation we want to be able to use. And we're going to go ahead and write these out by marking them as x1, y1, x2, y2. And all we're essentially doing is we're going to take them and plug them in. Now, I know you guys probably graphed it, which is awesome. We're going to do that as well. But we want to show these first. Taking our x values from these, our x's, we're going to add them together. -4 plus a -2 divided by 2. Then we're going to take our y's, -7 plus 7 divided by 2. We are going to get, what is that, -6 over 2 and 0 over 2. This would have been a completely acceptable answer. We want to take it one step further. Hey. Divide it out by -3. Get a little bit of midpoint. Graphing our 2 points, we're going to go back -4, down 7. I'm just kidding. Yes. Back to up 7. If I connect my 2 lines, that means just I have the midpoint at the middle of the line, which is at -30. This is a midpoint. Good beans? Okay. Good beans. Cool beans. Changing it up, man. Here we go. Do me a favor. Copy that down. Pull that out. We're doing a little bit of proof. Okay. One thing that we want to be able to see here is we want to be able to use triangles to show proofs. And we're going to look at 4 different types. Equilateral triangles show that we have 3 sides all congruent. So if we use this distance formula and we find that all 3 sides are congruent, then we're good. They're all the same. Isosceles means that we only have 2 sides. The third side is different. Scaling means all sides are different. And then at right triangles, when we find the slopes, we got to be able to see if we have any perpendicular slopes to them. Okay, so we're going to look at that. The one thing that I'm going to have you guys write down, and bear with me, I know you guys kind of copied that. I'm going to kind of get rid of this top portion. On your guys' notes as well, you guys have the following. Underneath this first part, right, you have that little blocky area. So we're going to write two separate things. The two things you are going to use today. So this is that box is right underneath it. The first one we're going to look at is just reviewing, and we're still going to look at slope. And our slope to this is still going to be the same. We also considered it. I'm just going to give you the different variations. y2 minus y1 over x2 minus x1. We also know it is our rise or dropping down to our left and right. We also know it to be our y's over our x's. And we also know it to be the rise over the run. These are all the variations you can look at slope. And it's important that we keep the negatives and positives with the slope. For our other box, the other one we're going to use today is distance. And it's important we're able to do distance and understand what that's providing us. And I think the one we're used to seeing is a squared plus b squared equal to c squared, which is the Pythagorean theorem looking for the triangles. The other way that we have also seen it is the distance formula, which is d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And again, most of you guys like the Pythagorean theorem, and that's the one we're going to use the most today. I think it's a lot easier to do, and we're going to be able to solve it out. Okay. Cool beans? Okay. Good beans. Good beans today. Yes? Okay. So let's look at these examples. If we want to show that a triangle is congruent on all three sides, it'll be equilateral. Two sides isosceles, no side scalene. If we're looking at the slopes and we find out that one pair is perpendicular, we have it right. So let's check it out. Let's check it out. Look at our problem down below. This is the beginning of our triangle. It says, determine the following type of triangle given. We're going to jump right into this because it's already graphed and we don't have to do that much to it. Okay, all it did is it took those points and it graphed it. Okay, so the first thing we want to be able to do here is we're going to do two things. We're going to find the distance, and then we're also going to find the slope zone, making sure that we either have perpendicular or none. Because we could also make them right. I'm going to color coordinate mine. If you would like to do it on yours, I would highly recommend it. But let's go ahead and find the length of one of our sides. Let's look at CB. I'm going to mark this on its side, CB. So we're going to find the length of CB. To find the length, I got to create the triangle, and I'm going to do that by doing the rise. So this is 3 over the run, which is 4. So I have my triangle parts of those, and I'm going to plug them into the the Pythagorean theorem. 3 squared. So 3 squared plus 4 squared is equal to c squared. What's 3 squared? 9. 9 plus 4 squared? 9 and 16 is going to give me, taking the square root, what do I get? 5. So this tells me the length of this part is 5. I'm going to write it on the inside of our triangle. So that length is 5. Does that tell us anything about the triangle? No, we gotta find more information. I'm going to do BA now. So let's do BA. It So I'm going to mark that in red for myself. So I'm going to go BA for the next one, and we're going to do the same thing. We're going to use a distance to find this out. So I'm going to go over 1, and it looks like we're going to go 1, 2, 3, 4, 5, 6, 7. Yes, you're right. So I'm going to have 1 squared less 7 squared is equal to C squared. 1 squared, 7 squared, equal to C squared. 50. 50 is equal to C squared. And I'm going to go ahead and just leave it as the square root of 50. I don't need to find out what that is because it's just a number. I don't really care about what that number is. So I know that C is square root of 50. I'll mark it in there. So what, looking at the top of those triangles, what's the first one we can automatically get rid of? Why?
Because they're not all equal.
They're not all equal. So automatically we can get rid of an equilateral. It's not equal. Okay, we got to do the last one. So these are what makes the proofs long, is we got to do it 3 times. So we're going to do CA. I'm going to go down how many? Over how many? So 4 and 3. It's almost the same one up at the top, right? It is. 3 squared plus 4 squared is equal to C squared. Can I just skip and jump around? We're going to get what? 5C. Okay, it's the same thing like the blue. It's the same thing like the blue above. Oh, no, listen. Listen, go. Okay. What does that mean that we have here? What does that mean that we have? Why is it isosceles? 2 sides congruent. Right behind you. Means what? Okay, let's go ahead and just do one more thing. Let's check out the slopes of these. What is the slope of CB? What's my slope? 3/4. What's my slope of BA? 7/1, not 1/7. What is my slope of CA? Positive or negative? Am I getting anything from that now? What do I know about CB and CA? So if they're perpendicular, what else does that mean? It's also a right. So we have an isosceles right triangle. Done. So we got to still do the slopes on these. So we're also doing the distance and we're also doing slopes. Did it take me that long to do? No. As long as you have them written out, I'm okay with you guys doing that. Got to keep the negatives with the negatives. That's why the top 2 over there, you got to make sure you guys have that. Okay. Easy or hard? Easy. Easy. Hard? Harsh. Long, right? It's just long. They shouldn't be hard. It's just long. Let's check out another problem. We're going to do 2 simpler ones before we jump into the next one, before we do the next big thing of doing it a lot. Because I do want to cover these for you guys. So here we go. Now, I didn't give you guys a lot of room, so my apologies, but I wanted to fit it on a piece of paper for you. So let's do this. It's not doing it for me. I got to reset it. It's hot. I'll kick on the AC. Okay, good. There it is. Just kicked on. I just looked at it and the light turned on. Say what? I don't need to. I get to control my AC, so it's kind of nice. So did we do this one? Maybe. We sure? We didn't do it? Okay. Let's look at this one. Determine the type of the following given triangle. So we got to be able to see what type it is. So let's go ahead. The first thing let's try to do, let's kind of just draw it out. So 1 is A. B is 4 5. 4 5. And C is 4 1. What type of triangle does it automatically look like? It's a right triangle. So do we really need to find the slopes of that? No, let's not go there. Let's not worry about that. So we definitely know it's a right triangle. Specifically, what type of right triangle? Scalene, right? It should be all 3 different sides. Now with this side, because it's on a flat base here, can we just count the length of that? What is the length of that bottom part? 3. We could just count it. It's simple. So let's say AC. Let's kind of write this out just in our formal proof. AC is going to be equal to 3. We don't need to do that much work to it. What about this other side, BC? 4. So look at that. We don't even have to do work for these. These are just simple. This is 4. Let's look at the third side. Now, do we 100% know that it's scalene? By this point, we should. But in order to show it in a formal proof, we got to show it. So we just got to do the distance between AB. So let's do that. I'm going to use the lengths that are already there. It's already made a good triangle out of it. So we're going to plug in 3 squared plus 4 squared is equal to C squared. We're going to get 9 plus 16. What's 9 plus 16? 25 square root of 25. So AB is just 5. So what type is it? Scalene right triangle. It's a scalene right triangle. Specifically, because our sides are 3, 4, and 5, does anyone know what we call those? Oh. No, consecutive. Not close, but it's not. How do we say it? Does anyone know what those are? What type of triangle that is? A 1, 2, 3. It's actually called the Pythagorean triple. Pythagorean triple. You would have never guessed it. I used to watch Jeopardy with my dad all the time. Family Feud. My wife still watches it. Okay, here we go. Let's look at another problem. Let's check it out. What does it tell us to show? That means what? How do we show it's not an equilateral? More simpler than that. Not all sides are equal. So as long as we show 2 sides are not equal, it's definitely not an equilateral triangle. So we're just going to do all 3 sides just to show for certain what it is. So let's graph out our points. This is going to get a little bit more advanced, so this is taking up one more notch. Okay. We are going to go back 2 up 4. Back 2 up 4. This is over 6 up 4. We're going to get ka. And, uh-oh. Did I make a boo-boo? Sorry, I was messing up with the back 4 up 4. Over 6 up 4. This is JK. And then L is over 2 down 3. Now, specifically looking at this, if we just had to take this off of face value, what does it really look like? It looks like an equilateral, right? Not necessarily scalene, but it looks like an equilateral, right? Isosceles. It looks like an isosceles, okay? But we got to be able to show actually what it's not. So if we were trying to prove that. Now, what would be the easiest one to solve out for? What side? Why JK? It's on a straight line. If it's on a straight line, we can just count it. So let's go ahead and just count it. That's one step we don't even have to do. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Is that what you guys got? So let's go ahead and just mark that just on the side line. JK is 8. Okay, but that's the only one we could really do. We got to kind of step up our game here. Got to be able to find the lengths of these this time. Okay, let's do the lengths of this. Let's do JL. JL. I'm going to go down how many? 7 over how many? So this is 7 and 4. So I'm going to get JL is going to be 7 squared plus what? 4 squared equals C squared. 7 squared is 4 squared is, adding them up together, we are going to get 65. Now, could someone tell me the decimal representation of this? What would C equal to? 8.1. 0. Is this? I thought it was 1. No? Am I wrong? 8.1? Is that rounded or not?
Rounded.
Yeah, we'll just round it. We'll round it up to the nearest 10th.
Yeah.
Nearest 10th, right?
Yeah.
Nearest 10th. 0.6. Fine, I won't round. Gosh. 0.6. We'll keep it not rounded. Okay. Can I just stop there?
No. Yes.
Technically, I could. It's telling us to prove it's not an equilateral. 2 sides are not equal. Not all sides are equal. Not an equilateral. But we're going to take it up the next step because we're next level people. We're on another level. But look at this one. What does this one actually give us? This one's 7 and this one's... So what does it actually give us? It tells us the same thing. LK is what? 8.06. We don't even have to do any work for that. So how do we kind of conclude this? How do we kind of say this? We can say no 2 sides congruent. Thus, and we'll use very fancy, thus isosceles. So nitpicky. Easy or hard? Fácil. Uno más, por favor. Yes? Here we go. Let's do one that has everything. So we're going to do both the slope and we're going to do both the distance to make sure everything's good. On your homework, you're going to have to do that. Let's look at this one. Do me a favor. Draw out the picture. Draw the picture. Right, Matthew? Our cell phones are away because we've been absent for the last 2 days. Did he just do this? Dale. Well, my wife is yelling at me. I'll just give her like a really awkward face. And she'll be yelling at me. I'll just be like, stop doing that.
And like, my brother, he gets super calm. He's like, that bothers me. Get mad!
Get heated. Back 3, down 6. 0, up 4. 5, down 1. Did we get the picture? Kind of, sort of. It's the Bermuda Triangle. Everything is lost. Okay. What type of triangle does this look like that we definitely see here? Scalene. It almost looks like right. It almost looks right here, right? It almost looks like we have a right triangle, but we got to make sure that it is or is not. So we're gonna do everything on this bad boy. So let's do it. I'm gonna show less work on here. My apologies, but I'm gonna show you the numbers. I'll give you the numbers still that I plugged in.
No work, okay. Yeah.
I'm still gonna show work. Just not showing a lot of work. DE. Let's find DE first. DE, I'm going to go up how many? 10. So I'm going to plug in 10. How am I going over? 3. 10 squared and 3 squared is 109. That means my answer will be square root of 109. This is my work for it. I'm showing a lot less, but I just want you should be able to do the same thing. Okay, show your work for it if you need to. I'm just kind of streamlining it for those that need to streamline. Let's do DE or DF, sorry, if I knew how to spell. And DF is going to be my bottom line here. So let me just write that in too. Let me do square root of 109. 109. DF is going to be what? I'm going to go up or over how many? Over 8? Up 5. Up 5. 8 squared is 64, 64, and 5 squared is 25, 64, and 25 is 89. That means my answer, when you solve it, will give me square root of 89. Automatically, what is it not?
Equilateral.
Equilateral. Do we know that for sure? Not isosceles yet. The only thing we can get rid of is our equilateral, because not all sides are equal. We could find out the DF is a isosceles, but I'm pretty sure it's not going to be, but it could. Maybe not in our universe. Somewhere else. We're going to use our last one here, which is EF. Again, if you need to create the triangles, by all means, please do it. We're going to go over how many? 5. Go down how many? 5. Okay. 25 and 25 is?
50.
So we're going to really get the square root of 50. What do we know it to be? So I'm going to write all sides different is going to be our first showing. Let's look at the slopes now. Let's do the slopes. Slopes are easy. Check it out. How far did I go up? Over how many? So 10 over 3 is going to be my slope for first one. My DF, how far did I go up? Up 5. How many did I go over? 8. So 5 over 8. And our last one, EF, how far did it go down?
5.
So negative 5 over how many?
5.
So you can leave it as that. That's fine. What do we know about all these slopes? None. Are, I'm going to abbreviate this, parallel or perpendicular. What can be our conclusion?
Scaling.
Scaling triangle. It's Illuminati. Cool beans? You guys good? Sure. Homework time?